All right. A transportation company owns 30 buses. The distance that each bus has traveled since being purchased by the company is recorded. The cumulative frequency curve for these data is shown. Find the number of buses that traveled a distance between 15,000 and 2,000 kilometers. Okay. So, wait. So 15, let me see if I can annotate. Hopefully I can. Oh, okay. That's fine. Okay, so you would look at the distance since it's asking for 15,000 and 20,000. You would look at 15,000, and when you go up here, can you guys see my cursor though?
Yeah.
Okay, good. Okay, so 15,000 correlates with 20, right? So that would be the number you're subtracting. So keep 20 in mind. And then it asks for 20,000. So you would go all the way up here. And since okay, so a way you could find out what the intervals are going by, since there is 5 values between 30 and 25 and 10 boxes, just do, what is it? 5 divided by 10. And then by that, you could see that each box is 0.5. So, geez. Okay. I think I'm losing my voice. Okay, so since there's 1, 2, 3, 4, 5, 6 boxes, you would do 6.6 times 0.5, which is 3. So 25 plus 3 is 28. So you would be doing 28 minus 20, which is 8. So there would be 8 buses that traveled a distance between 15,000 and 20,000 kilometers. Okay. Use the cumulative, oh gosh. Okay. Use the cumulative frequency chart curve to find the median distance. Okay. Okay. So basically you would want to look at, so for this one, there's 2 marks. Use the cumulative frequency chart. Okay, so based on your cumulative frequency chart, you would do, so you would look at this top number. So you would do 30 times 0.5, right? Is it 30 times 0.5? Yeah, so since the median is in the middle between 0 and 1, you could do 0.5, or instead of like really doing any math, you could just look at your cumulative frequency, divide that by 2, and you would get your median, quote unquote, and then you would want to see where that lines up with. So since there's 5,000 in between these 2 points and 10 boxes, you would do 5,000 divided by 10 and you get 500. So each of these boxes on the bottom are increasing by 500. So since you are looking at 15, you are looking right here, that's the second box. So there'll be 1, 2, 3, 4, 5, and then 6, 7. So 500 times 7 is 3,500. So you would do 10,000 plus 3,500, which is 13,500. So in the mark scheme, it says accept an answer in between 13,500 and 13,750. So I would just, since you have the math and the intervals, I would just say 13,500. Oh, stop me if you have any questions, by the way. 1C, use a cumulative frequency curve to find the lower quartile. So same deal. Since the lower quartile would be 0.25, you could do 30 times 0.25, which is 7.5. Or if it was an easier number to divide by, let's say 16, you could just be like, oh, 4. But it's not. So 7.5. Since we determined that each value goes up by 0.5, that would be 5.5, 6, 6.5, 7, 7.5. So 7.5 would be this line in between 5 and 10. So they're asking to find the lower quartile. So you would just do the same thing. You would go and hit the curve, and then you would just go straight down. So it would be 10,000 to 7.5. So your answer would be 10,000. Okay, 1D. Use a cumulative frequency curve to find the upper quartile. Same deal. Take your highest cumulative frequency, which is 30. Since it's 0.75, 3/4, you would do 30 times 0.75, and then you would get 22.5. So same deal, going up by 5. So that'll be 20.5, 21, 21.5, 22, 22.5. Same thing. It's a line in between 20 and 25. So you would just go until you hit the curve and then go straight down. So since each interval on the bottom is going above 500, it would be 15,500 and then 15,000 and then 15,500 plus 500 would be 16,000. So your answer would be 16,000. Hence write down the interquartile range. So we would use the answers we got from 1C and 1D. So basically the IQR is when you take the quartile 3 and subtract quartile 1. Yeah, because quartile 2 is the median. So it would be quartile 3 minus quartile 1. So since we got 16,000 for quartile 3 and 10,000 for quartile 1, you would do 16,000 minus 10,000 and you would get 6,000.
I'm sorry for saying this so late, but how would you do the lower quartile again?
Yeah, no problem. So since you see how the highest value for your cumulative frequency is 30?
Yeah.
So you know how 0.25 is 1 out of 4, like 1 out of 4, that would be you know how quartiles are like split into 4?
Mm-hmm.
So 1 out of 4 would be 0.25. And then your median would be 2 out of 4, which is 0.5. And then your third quartile would be 3 out of 4, which is 0.75. So since we're looking at, did you ask for lower or upper?
I asked for lower.
Okay, so since your lower is 0.25, you want to take the highest value you have on your cumulative frequency, like axis, the y-axis, take 30, and then you would multiply that by 0.25. And then you would get 7.5. So based on the value you get, you would use that, and then you would match that up with the curve and go down to the x-axis. Does that make a little bit more sense?
Yeah, and then you would match it with the distance. So that would be
Yep, yeah.
Okay.
Yeah, the same exact concept applies for the upper quartile. Instead of 0.25, it would just be 0.75. If that makes sense as well. Do you want me to wait or should I move on? Basil?
Oh, you asked me? Oh, I'm good.
Yeah. Okay.
Sorry.
No, you're fine. Okay. IF. Write down the percentage of buses that travel a distance greater than the upper quartile. Okay, so since the upper quartile, since we got the answer from 1D, since it was 16,000, and then since that matched up with, what is it? Okay, so this is pretty easy. So write down the percentage of buses that travel a distance greater than the upper quartile. Since the upper quartile is 75% out of 100%, you would just do 100 minus 75, and that would be 25%. So like, let's say, for example, they asked you, write down the percentage of buses that travel a distance greater than the lower quartile. Then it would be 75%, because it would be 100 minus 25, and you would get 75. So the answer, since it's just one mark, you would just write down the answer 25%. But if you wanted to show your work, you could do 100 minus 75 equals 25.
Wait, did you say lower than the lower quartile?
Oh, no. I was just referring to another situation. But since this question is here, write down the percentage of buses that travel the distance greater than the upper quartile. Since the upper quartile is 75%, that would be how much is remaining. That would be 25%. So if you wanted to show your work for that, you could do 100 minus 75 equals 25. Does that make sense? Mm-hmm. But like, let's say, like, for example, in another situation, let's say they ask you, write down the percentage of buses that travel a distance greater than the lower quartile. Instead of it being 25%, it would be 75%. Because in this case, you would take 100 minus 25%, which is a lower quartile. Does that make sense?
Mm-hmm, yeah.
Okay, great. And then 1G. Okay, find the number of buses that travel a distance less than or equal to 12,000 kilometers. Okay, so since we've established that each box is 500, so that'd be 10,500, 11,000, 11,500, 12,000. So that would be the line, that would be like the box right before the middle line. So go up, 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 up. And then since we've established that each box on the y-axis goes up by 0.5, since it's 2 boxes above 10, it would be 11. So 11 would be your answer for 1G. It is known, so we're on 1H right now. It is known that a bus has traveled more than m kilometers. Find the value of m. Okay, so since it's saying traveled more than m kilometers, we need to go from the top of the cumulative frequency down, right? So that would be 30 minus 8, which is 22. So that would be one of your marks. That would be one of the points. And then since we would get 22, that would be the box right below the line, the center line. And then go, hit the curve. And then that's like, I don't know if you guys can see that. Oh, okay. It's like 20, it's like right in the middle. So basically, because it's right in the middle, I would make an estimation that would be like 250. So since it's increased by one box, that'd be 500, and then like half of another box, 250. So I would say add 750 to this line right here. And since this line is 15,000, I would say add 750 to that. And then I would get 15,750. Hope that makes sense. But on the mark scheme, it also says that it accepts answers 250 below that and 250 above that. But if you want to be accurate, that's how I would do it.
Wait, why would you subtract 30 over 8 again, or minus 8 again?
Okay, so you know how what the information it gives is like, it is known that 8 buses traveled more than m kilometers. So you can't, so basically so it's saying 8 buses traveled more than, so you want to look at the extreme high. So because the cumulative frequency is of 30 buses, you want to subtract 8 from that and 22. So basically, the value you get for 22, like we got 15,750, like that kilometer, like that value is what the 8 buses traveled more than. Because if you see on the curve, 15, so that would be right here, right? I don't know if you could see the mouse, but it would be 8 buses, which would correlate with the 30 minus 8 equals 22. But since it's asking for how many buses traveled, 8 buses traveled more than m kilometers, you want to look at the top of the graph. I hope that makes sense. But Alan, do you know how to explain this a little bit better? Why do you subtract 8 from 30?
Okay, so from what I know, it's like it says like 8 buses traveled more than m kilometers, so I guess like you can just subtract 8, so you know that, so everything above 22, those are the buses that traveled more. Everything below 22, that's like
The buses that traveled less. Yeah.
That's the only way I can explain it, but yeah.
Does that make a little bit more sense?
So if it was talking about, it is known that 8 buses traveled less than m
Yes.
kilometers, would
Yeah.
you do it the other way around?
So yeah, exactly. So if it says less than, I think you would do 0 plus 8.
Oh, okay.
And then look at A and what A matches up to.
Gotcha.
I think that makes sense. I think that would make sense in the opposite situation.
Okay, that makes sense.
All right. Okay. One is, I don't know if that's one I okay. The smallest distance traveled by one of the buses was 2,500 kilometers, and the longest distance traveled by one of the buses was 23,000 kilometers. Sorry. On graph paper, draw a box and whisker diagram for these data. Use a scale of 2 cm to represent 5,000 kilometers. All right. So on your box plot, if you have your mark schemes out, that would be great, because I'm just going to talk and explain the mark scheme. But on the bottom here, right here. Oh, it doesn't give us an example. Okay. Never mind then. Okay. So here, let me screen share the mark scheme for a second. Okay. Okay, so since it gives you 2,500, that's the smallest distance, right? So that would be the minimum. So that's what this line here represents. And then since it says the longest distance traveled was 23,000, that would be the maximum. That would be all the way to the right. So basically you would use the values that you got from your other answers. Like remember we figured out median, we figured out lower quartile, upper quartile, and basically you would just take those values and you would utilize them here. So how we got lower quartile was 10,000. That would be the start of your box. Upper quartile we got 16,000, I think. I'm not sure, but that value would go right here, and then the median value would go right here. So that would be how you, oh Lord, that would be how you draw your box plot. Yeah. Does anyone have any questions?
I have one, but like, how would you find the minimum maximum from the graph?
Oh no, it gave it to us in the question right here.
That.
Yeah. But I think, yeah, no, there's no way you can find the minimum and maximum from the graph, because that's just like it connects the points, but it doesn't tell you if the point's actually there. Hope that makes sense. But like, yeah, you can't determine your minimum and maximum from a cumulative frequency graph. Okay, I'm gonna reshare the other screen. Okay, so if you're on 2A, oh wow, okay. Okay, 2A. Adam is a beekeeper who collected data about monthly honey production. In his beehive. The data for 6 of his hives is shown in the following table. The relationship between the variables is modeled by the regression line with the equation P equals AN plus B. So N represents the number of bees. Write down the value of A and B. So this is pretty simple. It's like what we've been doing, plugging in values. Put in all your L values into. No, that's right. Put in all the top values, like the number of bees, into your L1 column, and put in the this bottom row into your L2 column, and then go to line regression sub 1 bar stats. So that would be okay, and then L2. Okay, and then line regression, make sure. Okay, so the answer is here. A value, oh, okay, I did it wrong. But once you plug it in, the A value is supposed to be 6.96103. That would be your unrounded value. Make sure you have your unrounded value. And then your rounded value for A would be 6.96. And then for B, your unrounded value would be negative 454.805. And then your rounded value would be negative 455, because you want to keep only 3 sig figs. Okay, use this regression line to estimate the monthly honey production from a hive that has 270 bees. So basically you would take your values from 2A and then you utilize that for 2B, and you would plug in 270 to X. So once y'all have done that, one second. Okay, once y'all have done that, you should get, okay, also since it's 2 marks, make sure you show that you plug it in. So for example, for your work, make sure you write 6.96, open parentheses, 270, close parentheses, minus 455. And then make sure you also put your unrounded value just to be sure, which would be 1,424.67. And since we want 3 sig figs, you would round that to 1,420. So that's 0. Doesn't count under sig fig. So the 3 sig figs you have is 1, 4, and 2. All right. 2C. Adam has 200 hives in total. He collects data on the monthly honey production of all the hives. This data is shown in the following cumulative frequency graph. Okay. Write down the number of low production hives. All right. So since it says right here, P is less than or equal to 1080, we want to find 1080 on the graph, and then we want to match that up on the y-axis. So since there are 5 boxes and it's 600 to 800, it would be 5 divided by, no, it would be 200 divided by 5, which is 40. So that means each box increases by 40. So it should be, since it's 1080, it should be 2 boxes from 1000. So 1040 and then 1080. So if it is 2 lines after 1000, go up and it should hit 40. So it should be 40 hives should be your answer for low production hives. Okay. Next we have so 2D. Adam knows that 128 of his hives have a regular production. Find the value of K.
Can you scroll down a little bit, Mira?
Yeah.
Okay.
Is that fine?
Yeah, that's good. That's good.
Okay. Find the value of K. Okay. Okay, Alan, do you by any chance understand this and know how to explain it?
Yeah. Okay. So you know how we found how many like hives have low production, right? And we know that 128 of them have regular production. So you would add 128 and 40, and so that would give us 168. And then we'd find 168 number of hives. Like I can't do it with the intervals, but you'll find it, and then you'll like find it somewhere on the graph, go all the way down, and you'll end up, and that's how many, that's going to be the value of K, basically. Yeah. In the mark scheme, it's 1,640. That's the value of K.
Okay, so the value he got was 128 plus 40, 168. So that would be like 170-ish. So we would match it up right here. And then that correlates. Oh, no. Okay. Let me see if I can find a way to show this on the graph. 20 divided by 5. Oh, okay, that's fine. Okay, so also on this side, instead of going up by 40 like it does on the x-axis, it goes up by 4. So exactly what Alan was saying before, since we have 40 bees for low production, and then since it gives us that it tells us it has 128 hives for regular production, you want to add those and you get 168. So you want to find 168 on the y-axis, which would be the second box since it goes up by 4. So 164, 168, go right here, match it up with the line. Since it's one line after the line, one box after 16,000, that would be 1,600, that would be 1,640, because we've established that the boxes go up by 40. All right.
Wait, can you explain that again? Sorry.
Yeah, no, you're fine. Okay, so since it's asking, so let me go over the question again. Adam knows that 128 of his hives have a regular production. Find the value of K. So since we've established from 2C that 40 of his hives are they have a low production, we have the value of 40. And then since it gives us that 128 of his hives are regular production, we have the value of 128. So since we have a total of, no, actually disregard that. Since we want to find a high, we need to add up 140 and 128. So when we add 128 and 40, we get 168. So you want to go up 168 on your y-axis. So since we've established that each of the boxes go up by 4, that would mean it would be that second line above 160. And then you would match that up with the curve. And then since that's one line after, that's one box after 1,600, that would be 1,640, since we've established that each box on the x-axis goes up by 40. Hope that makes sense.
Yeah, I just think I got confused on why you added 128 by 40.
Gotcha. Yeah. All right. Moving on. 2E, find the number of highs that have a high production. So since you already have the values for low and regular, which is 40 and 128, you want to add those, you get 168. And then you want to take your highest value on the cumulative frequency graph, chart, whatever, and then you want to subtract 168 from 200. So you would get, okay, you would get 32. So you would want to do the same thing, go up 32 and then find, and then, oh no, actually, no, I'm overcomplicating it. Since it's asking us just to find the number of hives that have a high production, you would stop after you subtract 168 from 200, which would be 32 hives. Sorry for that. All right, moving on. 3A. Let me just see what the other questions are real quick. Oh Lord. Crap. Okay. Oh, that's not bad. Hopefully we can finish this. Okay. 3A. Find the probability that both people chosen are not allergic to nuts. Oh wait, let me read the information. A company performs an experiment on the efficiency of a liquid that is used to detect a nut allergy. A group of 60 people took part in the experiment. In this group, 26 are allergic to nuts. One person from the group is chosen at random. A second person is chosen from the group. Find the probability that both people chosen are not allergic to nuts. Okay. Okay, let me figure this out real quick. Okay, gotcha. So you do not need this chart to figure out 33A. So basically, you know how in the information it gives us that 26 are allergic to nuts? So based on that information, you could deduce that, you could determine that 34 are not allergic to nuts. So it's the same concept as the marbles and like the other tree diagrams we had. So basically your equation would be 34 over 60. And then since they want to find probability of both people, you want to make sure that your second denominator is one less than the first. Same with the numerator. So your final equation would be 34 over 60 times 33 over 59. So when you multiply that, you will get 187 over 590. And then you could either, I think you could leave it like that, or you can convert it to a decimal. No, yeah, you need to convert it to 0.317. So you could make sure you show your unrounded decimal or your fraction form before you have your final answer. And then moving on, we're going on to 3B. Okay, 3B. When the liquid is added to a person's blood sample, it is expected to turn blue if the person is allergic to nuts, and to turn red if the person is not allergic to nuts. The company claims that the probability that the best test result is correct is 98% for people who are allergic to nuts and 95% for the people who are not allergic to nuts. It is known that 6 in every 1,000 adults are allergic to nuts. This information can be represented in a tree diagram. Copy and complete the tree diagram. All right. So since we already know based off like with tree diagrams that each branch added up has to be 1. So you would just do 1 minus 0.006, and then you would get 0.994 right here. And then for the top one, 1 minus 0.98, you get 0.02 for the second branch. And then for this section, you would get okay, Alan, I need help here.
Okay, so in the I think in the question it like says that it's 95% for people who aren't allergic to nuts. So in that case, red would be 95%, I think, and then
got it. Okay, got it. Okay, that makes sense. So since it says, as Alan was saying, since in the information it gives us that, tells us that 95% of the people who are not allergic to nuts, their blood sample turns red. So you would put 0.95 right here, and then 1 minus 0.95 is 0.05. So that value would go right here. Okay, 3C. An adult who was not part of the original group of 60 is chosen at random and tested using this liquid. Find the probability that this adult is allergic to nuts, so right here, and the liquid turns blue right here. So that's pretty simple. So since it gives us the 2 conditions, find the probability that this adult is allergic. So that would be 0.006, we'd be dealing with that number, and that the liquid turns blue, which is 0.98, we will be multiplying both of these numbers. So when you multiply both of these numbers, you should get 0.00588, which is basically 6-fig form. Okay, 3D. Find the probability that the liquid turns blue. Gotcha, okay. This one's also not that bad. So since we want to look at the probability that the liquid turns blue, that is our one condition. So the first like step you would have would be 0.006 multiplied by 0.98, and then you would add, so since we determined that this value right here would be 0.994, and then this value right here would be 0.05, you want to multiply both of those values. So your final little equation should be 0.006 multiplied by 0.98 plus 0.994 multiplied by 0.05. Make sure you have all your work when answering this question like you would on a test. And then, yep, since you would not get the exact value, you need to round to 6-fig form. So you would have 0.0556. Okay. 3E. Find the probability that the tested adult is allergic to nuts given that the liquid turned blue. Okay, that the allergic to nuts is given that the liquid turned blue. Okay. So basically, your numerator would just basically be like what it gives you in the question. So it would be 0.006 multiplied by 0.98, because it's saying find the probability that the tested adult is allergic to nuts given that the liquid turned blue. But for your denominator, do y'all remember when we did 0.006 times 0.98 for 3C? That would be your denominator, which doesn't make any sense. Alan, do you understand?
Yeah, okay, so it's asking for the probability when the liquid turns blue, and then the probability, we found the probability in 3D, which is 0.5558, and that would be your denominator?
Yeah. Isn't it weird that what you're multiplying on the top basically equals the denominator, or am I misreading something?
When you multiply it from the top, that equals 0.588. 0.00588. Like
Okay.
denominator would be like what you solved in 3D.
Got it. Since the meeting's gonna end, it's up to y'all if you want to finish this problem and the next one.
Yeah,
Or-
I'm probably gonna head out and just keep studying like
All
the
right.
rest of the stuff myself. But I do want to ask just before time runs out. I was still kind of confused on whenever what was it? 2D. Whenever I asked for the value of k.
Okay. Value of k. So basically,
I'm just a little confused on that why you add 128 to 40.
So because you see in the chart where it says it gives you like 1080 less than p is less than or equal to k. So you want to figure out what that value is, and the only way you could figure out what that value is when you add the value you get for low and regular. So that would be 128 and 40. And by adding that, when you get 168 and match it up to the cumulative frequency chart, you get the value that the regular is encased in, that it's inclusive in. And then that value would be the value the highest value you could go.
Okay, gotcha. Okay.
I mean, no, it would be the value that stays there for then the high honey production. That's what the value it has to be higher than.
All right.
Hopefully that made sense.
All right. Well, I'll see you guys tomorrow then.
Yeah. See you
Thank
tomorrow.
you, Mira. That actually helped a lot. So thank you.
Of course. If you have any questions, me and Alan are free. But yeah.
All right. Good luck, everybody, on the test.
Good luck, y'all.
Thank you, Mira.
Of course.
Thank you, Alan.
Bye.
Bye, y'all.
Bye, Mira.